Hi team, welcome to ACE Professional. My name is Kareem Al-Jamali and I'm a Principal Solutions Architect at Aviatrix, part of the ACE, which is the Aviatrix Certified Engineer Learning and Certification Program. I'm very pleased to be the instructor for the self-paced ACE Professional course. In terms of agenda, you can disregard the timing as this is self-paced. We generally start by a recap on the problem that Aviatrix solves, things that you might have seen in the ACE Associate course. Then I take you through a co-pilot UI tour. Then we start going into the multi-cloud network architecture, transit networking, segmentation, role-based access control, user VPN, and threat IQ with ThreatGuard. Then we go into a bit into a deeper topics, such as high-performance encryption, active mesh, security, firewall networks, and site-to-cloud. The way the course is going to work is we're going to have a lecture or two, and after those lectures, we're going to have a lab that maps to those lectures, okay, so that we make sure that you ingested the content that we have discussed. Then we will go a bit into operations as well as distributed firewalling. So to recap some of the content that we had in ACE Associate, we're gonna just reintroduce the problem that Aviatrix solves. So as more and more enterprises migrate their workloads, their business critical applications to the cloud, there is a need for advanced functionality. And the other problem, specifically to multi-cloud, is that different cloud service providers tend to do things differently. I'm talking about the differences between AWS, Azure, GCP, OCI, and Alibaba. So looking at this reality, enterprises started adopting, for instance, Datadog for workload and performance and monitoring. If you're into data analytics, then probably Snowflake might become another platform that you would like to adopt. Similarly, Terraform from HashiCorp is somehow the de facto standard for automation across multiple clouds. And finally, on the networking and security side, Aviatrix is the de facto standard, is going to be the common language by which you can create, automate, and monitor your networking and security stack across all of these different public clouds. Okay, we'll touch more on that, but this is just as a reality of what is happening in different sectors or in different technologies and where Aviatrix fits in. Okay, so Aviatrix is all about secure cloud networking. And the idea is when organizations go and find themselves in multiple clouds, the first reality is these different clouds do things very differently. Even if you are a subject matter expert in AWS, you will go to Azure and you will find yourself with very little knowledge, because of the way the UI functions, because of the way of the differences, even a common architecture. You would have to go and figure out what is the best practice architecture in AWS versus Azure versus Google Cloud. So what Aviatrix does, it upgrades this native cloud networking experience by taking what these CSPs provide and adding additional automation, additional visibility, additional security, and giving you a single pane of glass, a single automation layer and monitoring to operate this infrastructure across these public clouds. Thus, in a nutshell, Aviatrix provides consistent multi-cloud networking across all of these different islands or different cloud service provider. It provides a ton of visibility and control, embedded security that is leveraged in, that has a lot of functionalities, which we will discuss in the upcoming modules, as well as multi-cloud automation, which is basically the ability to bring up and tear down infrastructure with Terraform. Finally, we are also able to extend this multi-cloud network into the edge, which could be your data center, which could be a co-location such as Equinix. So some of the top pains that Aviatrix relieves in multi-cloud networking, very common ones are overlapping IP siders. Generally, when developers start working on the cloud, they tend to think less about the IP and the network architecture. So they start spinning up different applications in different environments, leveraging default VPCs, or really not considering the overlapping IP challenge that might arise. Aviatrix solves this in different ways, and I think this is a great use case for leveraging Aviatrix. The other big problem that we solve is we automate the route propagation across all the VPCs, VNets, VCNs, across all of the cloud service providers, offloading the operational work from the administrators and architects of this environment. If you're coming from an enterprise background, you've probably done a lot of BGP. Generally, cloud service providers do not show you, you will not be able to see the BGP metrics, things like ASPath or MED. These become hidden and decisions are made not very clearly for you as an administrator. Aviatrix understands where network engineers come from, and we make sure that we to provide all the actually some of the BGP attributes so that you can perform traffic engineering and route manipulation to be able to deal with multiple use cases. The fourth item under multi-cloud networking is about extending this multi-cloud network to the edge. And there's a lot of benefit in doing that, which is basically leveraging the controller, the co-pilot, the same model, the same ability to monitor the flows, to do packet captures, everything that you have been used to using Aviatrix in the cloud, and to extend it into the edge of the network. There are other benefits of extending the model to the edge we will discuss in later modules. In terms of operational visibility and control, I think that's another main reason where customers adopt Aviatrix. It's the ability to look at flow IQ, or basically net flow, and visualize and search and save those searches. And this will give you a ton of information of what happened to that flow, what happened to that packet, in addition to this amazing dynamic topology. If you think about it, generally, when we used to be on-prem, customers used to maintain topology by Visio. The reality with cloud networking is this is not possible, because everything is an API. So you might put out a topology, and somebody in the next 5 minutes, somebody has created another VPC or added a gateway. Because the consumption model of cloud is much faster than on-prem, your topology will always be will not be in line with reality. So the dynamic topology mapping that Aviatrix provides is a live topology of what is happening across all your multi-cloud environment and to the edge. The ability to do packet captures, pings, and trace routes are another valuable tool in the tool set. And being able to understand how your cost allocation is happening, which departments and which environments are consuming the cost is another very important service that Aviatrix provides. In terms of security, we recently introduced the distributed cloud firewall, which is another interesting way to do security in the cloud, whereby we no longer send traffic to choke points, to only next generation firewalls where they have to do the job. We embed firewalling on all of our gateways, and we also even can extend this firewall model to the cloud service provider themselves by orchestrating their network security groups and security groups. This is, I think, a great shift in how you can architect and secure multi-cloud networks. Another topic is high-performance encryption, which is, in a nutshell, being able to do encryption without compromise, meaning compromising throughput. We'll also touch upon next-generation firewall insertion and automated threat detection and mitigation with ThreatIQ. Then there is the multi-cloud simplicity, agility, and speed. We've talked about Terraform. We have a multi-cloud Terraform provider, which allows us to spin up all Aviatrix resources across the different clouds. We also have integrations with self-service portals such as ServiceNow or other integrations that might be of interest to you. Okay, so a bit on the architecture, still at a high level. The way I want you to think about the platform is that there is a co-pilot, okay? And the co-pilot is where you define your intent, where you define what do you want to do. And this intent goes and pushes itself to a fabric, which is the Aviatrix airspace, which is basically a full mesh of gateways that is across these cloud service providers. And in order to complete the loop, these gateways will have to send telemetry, will have to send flow information, will have to send logging information, and a lot of other stuff back into the co-pilot platform, based on which you might want to go and make changes to your programmable intent. Okay, so again, this helps with application availability, performance, security, and even cost. Okay, so with the telemetry, what we're referencing is telemetry is coming again from the airspace, which is from the gateways. The ability to see the traffic, some security telemetry, cost telemetry, and application telemetry. On the control side of things, it is where we have the distributed cloud firewall and where we have the capability to do intelligent traffic control. And we'll touch more on this with upcoming modules. Okay, so the idea of intent that I've shown is basically we want to have like an if-then, or we want to think about if this happens, if this event happens, then we want to do some of these actions. And some of these actions could be either security actions or traffic control actions. On the security, we can obviously do allow or block. We can do things like network segmentation, meaning that we can separate dev from prod. We can do micro segmentation, part of the cloud distributed firewall. We can do things like threat detection, anomaly detection. On the traffic control actions, we can optimize the path. We can choose a high performance path. We can do packet captures and other actions. Okay, now let's get a bit deeper into the solution components. This is, again, something that you might have seen in ACE Associate. There are some changes to it, and I'll explain. So the first thing is the controller. The controller is the brain of the system. It's the central automation, management, orchestration, and control plane. Again, you can think about it like it's your SDN controller. It's the component that oversees the whole network. One thing to note is that many of the UI functions have moved to Copilot. There are still a few at the time of this recording that are not moved completely. But in general, I mean, very soon, most of the UI will actually happen through the Copilot. So the controller does a few things. Number one, it spins up the Aviatrix gateways, which is, again, part of the airspace, which is the distributed data plane. The way it works is you need to authorize the controller. So whenever you spin up your controller, you need to give it authorization to be able to spin up gateways and to control the networking and security constructs in the cloud service provider, which is, I'm talking about AWS, Azure, GCP. So what you do after spinning up the controller is you authorize the controller to be able to control the networking and security stack within these different cloud service provider accounts, in addition to the ability to spin up the gateways. Once you have done this authorization, then you are able to go and spin up the gateways within these cloud service provider accounts, okay? So the Aviatrix gateways, as we have discussed, are the data plane of the solution. The controller is not in the data plane, okay? That's a very important point to remember. So if the controller goes down, your traffic is not going to be affected, okay? It's the gateways that are the data plane component of the solution. So apart from spinning up the gateways, the controller does a very interesting thing. It controls the networking stack and security that is within the cloud service providers. What I mean by that is we control the VPC routing, we control things like security groups. Again, this is a huge value, especially when you think about the problem at scale. Having the ability to orchestrate the routing tables of hundreds of VPCs or VNets and the ability to manage security groups for all our gateways and the controller itself is a very important value that Aviatrix provides. The other function that the controller also provides is the ability to do service insertion and chaining with FireNet. Again, we'll have a full module on FireNet, but basically I just want you to remember, so the controller is the SDN controller. You can think about it. It's the control plane of the solution. You can spin the gateways from it. It can talk to the cloud service providers and orchestrate the constructs, the cloud constructs, and it can also manage the end-to-end life cycle of inserting layer 4 to layer 7 next generation firewalls. I'm talking about the Fortinets, the checkpoints, and the Palo Altos. And the other key pillar of the solution is the Copilot. Again, as I mentioned, some of the configuration actually, most of the UI elements have moved to Copilot, and there's still a few that are in the controller. But the Copilot moving forward is going to be your UI as a user. You're going to interface with the Copilot, and the controller and the gateways are yet to remain untouched. Okay, so apart from the UI being moved for many of the functions to Copilot, the Copilot also provides day two operational benefits. So it's the place where you can see the topology, you're able to look at the threats, you're able to see the flows. Again, I'll walk you through a UI tour in a few minutes, and you'll be able to see all of the functions that the Copilot provides. Okay, so if you remember the architecture from Associate, generally what happens is we have a spoke gateway and a transit gateway. The way to think about a spoke gateway is, if you've ever done like data center networking, you can think about it like a leaf. It's basically the gateway that is closest to the workloads, that lives in the same VPC as the workloads. And these workloads can be anything from Kubernetes to virtual machines to Lambda. So the spoke gateways lives in that VPC and attracts all the traffic. We're going to discuss this more later, but it attracts all the traffic from that VPC to the spoke gateway. And then so the moment we reach the spoke gateway, everything becomes encrypted. So we have the encrypted tunnels that go towards the transit. You can think about the transit like an aggregation or a hub layer. And you can have two VPCs that are connected to a common transit, or even hundreds of VPCs. This is in a region. You can extend the setup to another region, or you can extend it even to other clouds, okay? So the idea is now you have a single network, a single operational and visibility layer across this whole multi-cloud environment. You can also benefit from high-performance encryption, again, a topic for another lecture. You can do network segmentation, which at a very high level is the ability to separate dev, for example, dev environments from prod environments. You can think about it like VRFs, so the ability to operate two separate environments on top of the same networks and make them live like ships in the night without knowing about each other. Then we have the firewall, next generation firewall insertion with FireNet. We talked also about the value that Copilot provides. Then there is secure cloud access, which is basically in two ways you can think about it. Is one of them is connecting your on-prem, your branches, your locations into this multi-cloud environment. The second one could be connecting the remote users. Think about it like a remote VPN solution, so that these remote users can also access the applications and services hosted in the multi-cloud. We also have a lot of functionality in terms of securing egress traffic as well as ingress traffic that is going to the internet. We still maintain TGW orchestrator, which is basically before we had our transit architecture. We have the ability to orchestrate AWS TGW. Again, not something that we see, but there are some customers who still use that, and this is still an available option. Distributed firewalling, which we'll have a dedicated module for, provides the ability to do micro-segmentation, be it within a VPC or VNet, or even across VNets. We will discuss again this in a later module. you actually need a single Aviatrix controller for all the clouds. So even if you're running an architecture that spans even all public clouds, you only need a single Aviatrix controller. You can get started without a licensing agreement. You can go with the pay-as-you-go model. However, most customers who are running in production actually have enterprise agreements in place. I think on Copilot, what I'll do, I think these are some of the benefits that it provides, be it Flow IQ or App IQ. What I'll do is in the next section, I'll show you these in action. Okay, so next we're gonna go through the controller and Copilot UI. I'll be focusing more on the Copilot because this is where most of the management functions have been moved. Okay, so here we are at the Copilot. You can see the dashboard. The dashboard is really very nice. It shows you the total number of gateways. And if you see a green check mark, it means everything is looking good. And if you want to see these gateways and look at their detailed status, you'll be able to do that. You can also see how many of these gateways are transits. You can see how many site to cloud connections. You can think about it for now like external connections, which could be IPsec or GRE. How many of these connections are actually up and how many are down? What's the status of PGP? How many instances are there? Again, instances are non-Aviatrix gateways that live within these VPCs. How many accounts have we onboarded? As I mentioned, that the way, whenever you start Aviatrix, you need to authorize the Aviatrix platform to be able to spin up resources, as well as control the native networking and security stack within these different cloud service providers. So the way you might want to look at this is if you go to cloud resources, you can see cloud accounts. So this is all of the accounts that we have that are added. You can see an AWS account, Alibaba account, Azure, GCP, and OCI. If you want to add an account, obviously depending on which CSP you're looking at, you might have to provide different variables, and this is already explained in the documentation. So if you're looking at AWS, you can do it via role-based, or you can do it via access keys. Azure, you will have to provide the subscription IDs, app IDs, app keys. There are different requirements, as I mentioned, for the different clouds, but this is the first step you want to make sure you cross so that you are able to spin up the data plane. So going now back to the under airspace, you can go look at the topology, okay? And you're able to expand it and contract it. I'll just do it slowly just to show some of the things that we can actually do. So the first thing is, you need to look at the legend. So if you open, for example, AWS, this legend is for a VPC. There is a legend, which if I open here, for example, let me open this. You can see that the legend for the internal item here is the subnet, and you can see the user VMs, which are these, and you can see the gateways being the Aviatrix logo embedded in them. Okay, so again, it has a lot of benefits. So in a nutshell, what this means, what we're looking at is that we have a gateway that lives inside this VPC. This VPC has 4 subnets, for example. Based on what we're seeing, we are able to see the virtual machines as well as the Aviatrix gateways. In addition to that, if you go from this gateway, you are able to go into gateway diagnostics. And this is very interesting because you can do pings, packet captures. You can choose on any interface. You can run a packet capture, and you can download the PCAP file directly from here. You can do trace routes, trace path. You can see the active sessions that are going through the gateway at this minute. You can look at the interface stats on a certain interface, and so these are some of the interface stats for Ethernet 0. If you look at a certain tunnel, you can also see the same. Maybe there's so if you look at the interface stats for Ethernet 0, you'll be able to see how much data has been sent and received, what's the IP address, and some other metrics that you might be interested in. You can see the state of the different services that are running and restart the services. This is generally what you use, but mostly I think what we'll be using is the ping, the packet capture functionality. Obviously, you're able also to zoom it in by specifying an IP address so that you're not doing a packet capture for everything, but you only want to see the relevant traffic. That is what you're trying to troubleshoot or look at. Okay, again, all of this is possible from the troubleshooting view. The other interesting value is if anybody were to give you, for example, an IP address of something that is not working, you are able to place that in a search, and you're able to figure out that, hey, this is the VM, this is the name of the VM. You can even get the size of the VM. You can know which subnet it lives in. And basically understand which gateway is the gateway you need to start looking at the problem from. Okay, so let me just remove the filter. Another interesting value is if you click on the link, again, this is the VPC that we're opening. If you click on the link between the spoke and the transit, you will be able to see the latencies we have between the spoke and the transit, because both of them are in US East 1. Thus, the latency you can see is pretty low. Okay, kudos to the AWS backbone. If you are, for instance, to look between AWS and Azure and you click on this link, you can directly see that we have a much higher latency between AWS and Azure. Someone might ask why are, for example, when we looked at this this latency on this link, why are we seeing 4 values? Reality is because inside this spoke VPC as well as inside the transit, what we're having is we are having multiple gateways. So in this case, we have 2 transit gateways and 2 spoke gateways. So let me just try to visualize it here. So we have a pair of transit gateways and a pair of spoke gateways. Again, and what we're doing is we have tunnels from the spoke going to each transit. And this is why we can see 1, 2, 3, 4 tunnels in total. And this is why we have 4 latencies when we click on the link between the spoke and the transit. Okay. Again, as I mentioned, you're able to search for any name, any IP address, figure out where it lives, go to the respective gateway, and do any of the packet captures or check the active sessions or do a ping and start your troubleshooting. Again, the other value which that's very important to always mention is this is showing all your multi-cloud environment. So this is showing AWS, Azure, GCP, OCI, Edge. Okay, so all of these different sites are being shown, and the different legend actually explains what each item within the different cloud service providers mean. Okay, so this was a bit on the topology. Another interesting thing to mention while we're here, again, I'm not going to go through the whole thing, but another interesting function is the builder functionality. It's a very nice way to build, I would say, parts of your multi-cloud environment in a visual way. So what you could do, I just want to show it at a very high level. I'm not going to go through it, but you can say, I want to build in AWS, and I have only one account that I onboarded in my AWS on the Aviatrix platform, and I want to do it, for example, in EU West 1. So you can start building inside this region, and you can say, I want to build a spoke. And maybe you want to use the existing VPC, or maybe you want to create a new VPC. You can even create a VPC and put it CIDR, and this will actually create a VPC for you. But let me just, for the sake of this flow, just go through. Let's say I have an existing VPC. I'm going to call my gateway test demo, and I'm going to give it a gateway size maybe of a T3 micro. I don't want to have high performance encryption on. And then I have to choose, for example, this is my primary instance. If I want to choose another gateway, I can choose another gateway and place it in another AZ. And maybe I want to connect it to one of these transits. All of this flow I was able to do from this single, I would say, wizard or single deployment model in a very visual and very easy way. So in this way, I will deploy 2 gateways inside this VPC that I selected. They will be placed in these subnets. They will be allocated an elastic IP address, and they will be connected to the transits. High performance encryption will be turned off on the gateways. Okay, I think this is very, very interesting if you're getting started and you want to build something very quick. So moving out of this, you can go to the gateways. So this is the main overview page of the gateway. So it somehow shows you some statistics on which gateways are mostly utilized, highest packet drop rate, or the ones that are least utilized. So we always look at gateways as mainly transit gateways, which are again the hub, or spoke gateways. So the transit gateways, from the Copilot, again, today, you are able to create a transit gateway. You can decide, as always, in which CSP you want to create that gateway, in which account. If you have multiple accounts, you will see them and then select one of them, and you will select a region. You will select a certain VPC. You select the instance size, as we have done from the builder, HP on or off. You can decide to pair it with other transits. And now inside this, I want you to look at this gateway on top, like a gateway group. So a gateway group is like, basically we're grouping gateways so that we are able to have multiple instances inside that transit gateway. Okay, so if you look at it like, I want you to think like whenever we created the transit gateway on top, we are just defining the properties of the group. And again, the group needs to be homogeneous, meaning that obviously all of them will have the same instance size because we're looking at them as like the same thing. So now when you create the group, you can add how many instances in the group do you want to have. Okay, generally for transits, we can have up to 2 transits today. Okay, this might be something that might change, but the concept is the group is like a folder, and the instances within that group are how many actual gateways do you want to build. So again, moving back to the, so here you will have to choose where is the gateway, which availability zone or which subnet do you want to place the gateways in. So you can say that I can click another, but I will not be able to click, sorry, I choose another. I will not be able to click another time, especially for the transit gateways, because on the transit gateways, I am limited to having 2 transit gateways. If I go to the spokes, you will see that I have much more freedom of adding up to 15 spoke gateways in a gateway group. Okay, so the outer thing is like a gateway group, and the instances are the actual gateways within that group. Again, the same logic. And once you have an existing transit gateway, you can go and, by the way, what it also shows you here is the number of transit gateways you are paired with. So you can see that you're paired with the other 3 transits you have, and you can see how many spoke gateways are connecting to your transit. If you want to edit any of the settings, for example, if you have another transit that you want to pair with, you can add it here. You want to pair maybe with AWS Transit. If you want to change the size, this is something you can actually also make the changes for. If you want other settings that you want to change, you can click on it. Here you'll see, as I mentioned, the 2 instances that comprise the that are part of the gateway group. You can see in which subnets they live, what are their private and public IP addresses, and what is their status. You can see the connections. You can look, for example, at the transit to transit peering, which is basically the peering with the other transits that I've showed you. You can look at the backup peering, which is the peering between the 2 transits. So what we're talking about here is, again, if we go to that gateway group concept, whenever we created transit 1 and transit 2, there is always a peering. There is always a peering between the transits, and I'll explain probably why this might be needed, okay, and in which situations will this link be used. But this link is actually always there. Okay, we call it the backup peering. And the transit-transit peering is the peering with other other transit gateway that we talked about, like OCI, GCP. You can see the transit spokes. So you have here 2 spokes that are connected to it. If you have edge, we actually even have edge here, edge gateways that are connected to this transit. Okay. You can also look at the gateway routes. Again, you can choose which instance, meaning, remember, we have 2 instances in this group, and you are able to look at each individual gateway's routing table. You're also able to benefit from the search. So for instance, if I were to look at this prefix and I want to do 10.10, you can see directly that the prefix gets filtered. Okay, and you are able to open only the relevant, I would say, entries pertaining to your search, and to see which one is being chosen. So this is how you can use the search. The other one, if you're running network domains, which we'll discuss, you are also able to zoom in into one of the VRF's routing table or one of the network domains routing table, as we'll explain in upcoming modules. The route database shows additional information, especially when it comes to the BGP attributes, things like the ES path length, the ES path, as well as the MED. We'll talk about route approval in an upcoming lecture. And finally, on the settings page, there are some settings that are commonly used. One of them is NAT. Again, we'll have a discussion on that. Then there is some common settings that are used, things like connected transit, multi-tier transit. I'll explain all of these in an upcoming lecture. BGP settings, for instance, what is the local AS number? You want to do ECMP with BGP? Do you want to have any manual advertisements? All of these different settings. Then there are some routing settings that can be tuned. So all of this is under the gateway itself, under the settings menu. Okay, if we go to the spoke, it's exactly the same thing. I cannot really think of major differences between the two. Gateway management is, again, one of the new functionalities that have been migrated to the Copilot, which is the capability of upgrading the controller as well as the gateways to a particular version, right? So now you can manage all upgrades from the gateway management page. I won't worry really about the GCP global VPC configuration for the time being. So let's just move on. On Edge, we'll discuss Edge in a later module, but in a nutshell, it's about extending the Aviatrix fabric into either an Equinix or your own data center, or even branches that need access to the applications in the multi-cloud environment. Okay, you can here see the edge gateways, and you can see which transit gateway they are connected to. Another very interesting functionality is scaling. So in a nutshell, what you can do with scaling, there are three different types of scaling. There is the manual scaling. One important thing about manual scaling is that we do not do the scaling for you. However, we alert you, and you as an administrator will have to come and actually do the scaling by yourself. So we are just alerting you that the scaling, there is a recommendation that we do the scaling. So the way it works is you will give the policy a name. Let's call it, I don't know, test scalings. And I will need to choose which VPCs or VNets I would like to do the scaling on. What are the conditions? And there's a lot of conditions. CPU, memory. The other one that I really like is bandwidth ingress limit, for example, exceeded. And what this allows you to do is whenever there are some drop packets that we are aware of, you can actually scale the gateways, or you can use CPU or memory. And this is the evaluation period is that we want to make sure that this condition is happening for a period of time. We don't want to scale just based on a microburst or a very short-lived condition where the metric exceeded, for example, 20% or 50%. We want to make sure that this condition is sustained for a particular period of time. And then you can have different ways of scaling. So I'll probably explain just on diagram. There is what we call horizontal scaling and vertical scaling. So a horizontal scaling, let's start, with the vertical scaling. Vertical scaling is you have a gateway that is of a particular size. Let's say a T3. Let's say we have a gateway that is a T3.micro. And let me get this under the gateway. And if we actually need, based on the metric being exceeded, we might want to get this, for example, to a T3. This is the same gateway, but now we want to change it to a T3.large. Okay. This is called, okay, vertical scale. Okay, because it's exactly the same instance. We're just increasing the size of the instance from a T3 micro to a T3 large. Okay. Another possibility, and this is in the UI, this is called scale up and scale down, and the description makes it even easier to understand. It's increasing the instance size or decreasing the instance size. So you might have a condition where if the CPU, for example, goes above 60, this is where you go and you do the scaling up. And then when the CPU goes down below the metric, this is where you can go and scale down the instance back to another instance size. Again, as I mentioned, with manual scaling, we do not do the scaling for you. However, what will happen is whenever the condition, and by the way, you can have multiple conditions and you can decide if you want to have them as an and or, so you can have CPU and memory together, or CPU and ingress limit exceeded together. Any of the metrics that make sense for the environment. And we can send a notification, and this notification can come in the form of an email, or it can come in the form of a webhook, okay, which can be integrated with things like ServiceNow, or even Slack, or any other tool set that you actually leverage. Okay, so this is on vertical scaling. Now, in terms of horizontal scaling is basically you have a gateway. Again, that is, let's assume T3.micro. Okay, so we're doing the same thing. This is a T3.micro, but instead of making it bigger, what we do is we go and launch another instance next to it. And that instance, for example, can also be a T3 micro. So we went from having a single instance now to having two instances that are sharing the load. Again, during the condition, and if the condition no longer exists, we can go and tear down the additional instance that we added. Okay, so I just want to make sure that what we're doing in this case is we are adding another instance to this instance, so we are ending up with two instances. Okay, for example, versus here, it's still that one instance that did not change. It's only the size of that instance that actually grew. Okay, again, worth noting that manual scaling is not actually doing the scaling. We are just generating the recommendations, and you are only getting, you will be alerted by, depending on how you want to be alerted of this condition, so that you will actually take the scaling action on your own. In terms of schedule scaling, I think that's also a very important feature where many customers have events or launches of products, and they want to make sure that we have our gateways scaled in the proper manner to be able to take the required load that they anticipate. So you're able to say, again, you're able to choose which VPCs or VNets you want to do, and you will decide when do you want to scale out and when do you want to scale in, and you can choose any of the days, and for example, the time where you want to scale out at, and what time do you want to go back and scale in at. Again, this is a horizontal scaling discussion for scheduled scaling. Okay, as always, you can decide to who to send the notification, but here it's important to understand that the scaling action is performed by the system. You're not being it's not about recommendations here. It's about the Aviatrix platform taking ownership of scaling out and in at the schedule that you have actually specified. The final option, which is again part of a preview, is the automatic scaling. Again, it's about horizontal scaling, where scaling in and scaling out. So you can see that it's the same thing. You can specify the VPCs or VNets. And what we're doing here is you are specifying that your ideal operating range is between so and so. I think for automated, you can choose either CPU or memory, or even a condition that has both of them together. You can do and or, as always. So whenever we exceed the ideal operating range, for instance, if we put an or, so it will be for any of them. If we put an and, then it will be for both of them have to be true. Again, we always evaluate that for a period. And this is where we can actually scale out and scale in. Again, in this mode, so the only mode where we're only generating recommendations is the manual scaling. For scheduled and automatic, we are actually doing the scaling. The platform is actually taking care of the scaling. here you will be able to see the recommendations. And whenever you see the recommendations, it basically means that this was a manual scaling, because this is the system just saying, hey, I see a low CPU for this VPC or VNet. If you want to scale it down, you just need to take that action. Okay, and events for any actions that actually happened, you will be able to see a history of the events of scaling up and scaling down, events that happened in your environment. So coming to networking, by the way, what's nice is if you want to search for anything, I generally don't remember where each item is. I can use, for example, topology. I can go and search directly here and I'll find topology. So you really don't remember where need to remember where every item is. So network segmentation, we'll go over it in a module, but in a nutshell, it's about creating different network domains or different VRFs, and being able to see how many, for example, here you're able to see the different domains with the different colors as per the legend here, and if there is a relationship between the domains or if they are isolated. Okay, this even becomes a bit clearer. This one shows which entities are part of the domain. This one just shows the domain itself and the relationships between the domain and the other domain. For instance, looking at this, you can see on-prem talks to production, development, and test, but it does not talk to edge or does not talk to site to cloud Europe. So this is a very easy way to tell if two entities should be able to communicate or not. I'll go through some interesting, I would say, features. On distributed firewalling, let me just explain the idea. I'll probably, you know what, I'll probably leave it to the lecture. I think it will make more sense once we get there. I'll go through ThreatIQ and ThreatGuard. So ThreatIQ and ThreatGuard is a very interesting, and I would urge anyone really to actually have it on, because it provides a lot of benefits and is very easy to configure. So the idea is as follows. The idea is we have, let me just, before I go here, we have something called FlowIQ. So FlowIQ is basically the net flow data. Remember that when we talked about the architecture, there is the gateway sending telemetry information back to the platform. So all of the part of the telemetry information that is sent is the net flow data. So all of the net flow data that passes through our gateways is actually stored, and you can search it and visualize it within Copilot. Okay, so and this is what FlowIQ is all about. So FlowIQ is an application that shows you all the packets, and this is, by the way, for the last 15 minutes, I'm able to make it last 24 hours. And if I do apply, you can see that the whole data is changed. So for instance, if you, and what's nice is you can zoom in into anything. So if I click here, it automatically writes the expression for me. So I'm looking for anything where source IP is 10.3, and I can see who are the destinations. Some of the destinations are private addresses. So I can click, for example, on this, which is going to a public address. I can figure out the source ports. I can figure out that this was an SSH session. I can get some data on the autonomous system numbers. And I can see which Aviatrix gateways actually have seen that SSH traffic going out from this particular IP to that destination. If I'm interested in going more in depth, I'm able to go into the record and see exactly what happened to the packet, on which interface it came, on which interface it left. If I want to even zoom in a bit more, I can choose, because the thing is, I have seen this packet multiple times. What do I mean by this? If I have, let's say, a gateway, another gateway, a third gateway, and a fourth gateway, okay? And I'm gonna draw the Copilot, for example, like this as a platform. What is happening is, as soon as the packet goes through the gateway number one is gonna send its flow information. I have seen this packet. This is everything I know about it. This is the 5-tuple information and any other statistics, how much packets sent, bytes sent. All of this information is going to be sent from this gateway. So this is the first gateway that sends it. And then once the packet goes to the second gateway, again, the second gateway is going to do the same. So the Copilot now has 2 copies of the same packet because it's being passed by different gateways. So gateway 3, gateway 4. So at the end of the day, you will have, for example, 3 to 4 instances of this exact packet being stored in Copilot. This is what the below, I would say, below tab is showing us. And you're able to zoom into one particular gateway and say, you know what, I want to know what did this particular gateway do to this packet. So if I go to the records, now I'm looking, if you look at my search, it's the source destination, but I've also added the condition of the AWS transit being the gateway. Okay, so if I look at the records now, you just get out of here. So if I look at the records now, you are able to see what actually happened with that packet. Again, this is the host being the gateway, this is the source IP, and this is the destination IP. Where did the packet come from, on which interface, and where did the packet go on which interface? Okay, so all of these details are available within FlowIQ. And what's nice about it is if I need the search, if I am in ops and I might need this information again, I can actually save it and give it a name that is relevant to my environment. And then whenever I want to search it back, I'm always able to load that view. Okay, so the reason I explained FlowIQ is because we see all of these flows. And if I just get this out of the way, I'm back to see the whole traffic. Maybe, again, I can maybe last 60 minutes, for example, and I apply because I don't want to see everything. So because I see this FlowIQ and I see all of the packets that flow through the platform, another interesting application that can add on top of this is ThreatIQ and ThreatGuard. So now with the information all stored in Copilot, right? How can I can actually know if there are any packets that are coming from known bad IPs or that are going to bad known IPs and domains. So the way it works is very simple. Let me just try to, again, annotate. So inside Copilot, again, right, we agreed that we have a table, okay, or basically the flow information, right? It's all there. The flows are all stored. And the other thing that Copilot does is it fetches, it goes and fetches threat information from Proofpoint. Okay, so we are subscribed to Proofpoint's threat intelligence service, which is one of the best known in the world. So what we do is we go and fetch information from our threat intelligence service, right? Threat intelligence service. And what this is all about, it's all about knowing these, any bad IP address on the internet. These are bad IP address. So an incident happened in, let's say, Brazil or anywhere in the world, we are able to know that these are the IP addresses that were involved in this malicious activity. So this threat intelligence database will collect all of the known threat intelligence across the globe and provide it to you as a service. And because we have all the flow information, we are able to match if any of our flows actually are going to or are coming from known it's all about here known bad IP addresses or domains. Okay. Okay. So this is what Threat IQ provides for you. So you can see that, let's say, for the last 24 hours, we have approximately 276 threats. And you can see the total number of threats that we have seen on the environment. So for instance, if you go and see any of these, for example, flows, you're able to see, hey, there was a flow that was coming from this IP. When it's marked in red, it means that IP has a malicious activity. It was targeting this private address within our network. If you view the details, you're able to see where in the topology So if you look at the threat, you can see the flow data. Okay, so you're able to see the source destination. You're also able to look at, for instance, for us, the source address is the malicious address. So you're able to see where that IP address in. Again, this is relying on geo IP information, so this might not be always accurate. There is the net flow, the full net flow packet, if you want to have a look at any of its details. And you can see the threat summary. The threat summary is all about why was this IP address considered a threat. So it tells you it is classified part of a miscellaneous attack. It has a poor reputation IP. So this is the reason why, and it gives you the severity of this IP address, which is major. So this is some of the information you can see within the platform. The other thing that is really interesting is if you go to configuration, just load for a minute. So you'll be able to see on the total number of threats that have been blocked, how many rules we have programmed, how many gateways we have, where are the rules actually being programmed on. You'll be able to see, for example, we have a gateway, PSF gateway, that has the majority of these rules because generally it's at the edge. What you can do is you can look at a gateway. Let's choose this, for example, Spoke 2 doesn't have a lot of threats. And all of these rules have been automatically programmed for you. And the way the rules work is we block, let's say this 185.14.97.176 is a malicious IP. So we're blocking traffic from anywhere to this IP and from this IP to anywhere. So traffic is blocked from a known malicious IP address in both directions. And the reason you see it says 33, it said 33 threats blocked, but it has 66 rules, is for each of these threat IP addresses, we have two rules, one for traffic that is going to this bad IP and one for traffic that is coming from that bad IP address. Okay, so again, what's nice is for anything you need for this feature, all what you need to configure is these two clicks. You want to say, when a threat is detected, send the alert, okay? And you can decide where do you want to send the alert. And if you want to block the threats or not. So some customers, whenever they start looking at the feature, they start with only the alerting. And the alerting, again, can be in the form of a webhook or can be in the form of an email, or you can configure the system automatically to block it. What's nice is, again, we are blocking on all our gateways. So regardless if we are in AWS, Azure, GCP, OCI, or Alibaba, the moment we have a threat, we are automatically able to block it for you. Okay, I think this is a good intro. So on egress, we'll discuss egress in a lab. For smart groups, I'll explain those. Again, they have to do with multiple functions, but one of the main use cases is distributed firewalling. Flow IQ, I already showed you Flow IQ. Performance here is if you have any of your gateways and you would like to look at certain metrics for a period of time, you are able to, for instance, graph them. And if you want a live view, you're able to toggle that on, and then the view will continue to change with changes in that metric. Traffic and latencies, this also can show you which regions, for instance, have the highest traffic, okay? You'll be able to see it on a per region, on a per VPC, on a per gateway, and even on a per instance. So you'll be able to have a lot of intelligence, basically, and to get more insights onto where is most of your traffic being sent from. The other one is the latency. So you'll be able to choose any two gateways, for instance. Let me choose AWS Spoke 1 and AWS Spoke 2. And this will show the latency between, for instance, Spoke 1 and the transit, Spoke 1 and the other transit, as well as Spoke 2 and the transit. And even I can why is this interesting? Because if you had an incident, for instance, where the application became slow, you're able to look at this data and try to figure out if there was an increase in the latency in the fabric that might be attributed to maybe a CSP issue. So you're able to see the notifications here. Obviously, the most common ones would be the threat IQ, threat guard. You're able to configure here all of the alerts, and there's a lot of them. Nowadays, even in the newest versions, they have the global network health, which is interesting, as well as the global control plane health. So the idea is these are automatically configured for you. So for instance, if the CPU or memory or anything really about the health of the control plane, meaning the controller and co-pilot, has a problem, you can automatically have these sent to a particular areas or a particular group. And then the global network health has to deal with the gateways. Okay, so this is like the data plane, and this is the control plane. These are automatically configured for you. And then if you want to configure an alert, you will be able to say the name of the alert. Do you want to touch the gateways, or do you want to touch the control co-pilot? You can choose which gateways, or maybe all gateways. If you don't do anything, it could be all gateways selected. Maybe you want to do if the BGP peering changed, if the gateway status changed, if the connection. So depending on what you want, really, you can choose any of these, and you can add multiple conditions, as always, and or. And you are able to, for example, you can do the connection status, and you can say if the connection is down, I don't know, for a period every 5 minutes, and you can, again, send an alert. If you have it for each gateway, do you want a separate alert for each gateway, or do you want us to have a single alert where we concatenate all of the gateways that are affected into a single alert? We can have it both ways. So this is a bit on the alerting. You can configure here the recipients, and as we discussed, it could be either email addresses, or if you want webhooks. You can see most of them are being done with Slack, for example. In this example, there's IFTTT that caught my attention here, but basically anything that supports a webhook can be integrated with Copilot. In terms of the troubleshooting, there's App IQ, and if you go to flight path, again, I'm just choosing a few things that might be interesting. So if I go App IQ -AWS, so this is an instance in AWS, and I can choose App IQ, for example, -GCP. And I can do it, for example, ICMP. So I want to check, I have an instance in AWS, I have an instance in GCP. I want to check if it can actually ping it on its private interface, not on its public interface. I have it run. And what's interesting about this is that it will collect everything it knows about from Aviatrix side as well as from the CSP to try to give us an understanding if these two instances, the AppIQ GCP and the AppIQ AWS, can communicate. So you can see that it has a very nice visualization showing the VPCs they are in, and then the spoke connected to transit even shows you the latency data. Transit connects to the, this GCP transit connects to the AWS transit, and then the AWS transit connects to the AWS spoke, and then we go to the instance itself. It will show us some details on the latencies in the path. It will show us if any of the gateways are doing okay in terms of memory, bandwidth ingress limit, if there are packet drops. Here it shows you if there's any flow data between them. So, and then it starts showing you on each instance if there is a problem, basically if there is a problem in this path. So if you look at AppIQ AWS, it starts looking at the network ACL. Again, the network ACL is an AWS construct. So it sees there's an outbound rule that allows traffic outbound to anywhere, so that should not be a problem. However, when we look at the route table, okay, we need to look at for a route that has to the 10.8, which is basically where the GCP lives. And because there is no route to 10.8, this is why we expect that we will not be able to have traffic between these two instances. However, it shows you the other items, even after something failed. It shows you the security groups, and it tells you that the outbound traffic is looking good. It shows you the route table. This is the gateways route table. There is a route that points to transit. It shows you now the transit gateways route table, right? Because after the gateway, which is our spoke, which has the route, we look at this transit, does it have the route? Okay, so again, bit by bit, it takes you, this is the transit gateway route table. And again, if you look at GCP's perspective, you can see that it has the route table to 10.8. Okay, so basically it takes you through all of the checks on both of the source and destination instance, what we know from the CSP and what we know from Aviatrix side, to try to tell you whether these two instances can actually communicate or not. Okay. I think that is the other one. I think that's also interesting to touch upon will be cloud routes. Cloud routes is really an aggregation that shows all of the routing information, be it within our gateways. You can see the different gateways, or even the routes that we have from the CSP. So you can see AWS, you can see GCP, OCI, and this is a ton of information, because if you want to look at these, you have to log into each CSP to go into these routing. So we make this job much, much easier for you, and you are able to search for a particular route. You are even able to zoom in. For instance, maybe I just want to see shared services, maybe anything that has shared services. So I go and search this one, I get this route table. Maybe I want to search for example, a particular route. I can even put the route I would like to search for directly. Again, this applies for both the gateway routes as well as the nice thing here about the gateways, it tells you its status, it's the tunnel status, how many tunnels and how many routes are there in the routing table. If you want to launch the diagnostics, just like I showed you there, this is again available from here. If you want to search in FlowIQ, you're also, this will redirect you to, sorry, the topology, and it will zoom in onto the gateway itself. If you want to look at FlowIQ, this will give you all the flows. It automatically filtered the host to be that particular gateway. Okay, so, and generally, if you want to look at some of the details of the gateways, it takes you back to that page where you see the routing information or any other information that is pertaining to that gateway. I think this was enough regarding the UI tour. Next, we will head back to our lectures.